An object that moves with simple harmonic motion can be described by an equation that looks like this. And so we've seen that this thing, omega, is called the angular frequency. And so what we want to do is we want to relate this angular frequency to the period of the oscillation. So this capital T is the period of the oscillation. That is the amount of time that it takes for a thing that is bobbing up and down to complete one whole oscillation. So how can we figure out how this omega is related to this T? Well, let's look at the function cosine of theta. So here's a sketch of the function of cosine of theta. Theta's on the x-axis. On the y-axis, I'm going to plot cosine of theta at 0. It starts at 1, and then the function kind of just goes up and down and up and down, and it repeats itself every 2 pi. So remember, omega times t, that's the angle that corresponds to a given amount of time, right? And so the angle that corresponds to the period of the oscillation is going to be omega times t. This is the angle that corresponds to the period of the oscillation. So angle for a full period, a full oscillation, right? Well, that angle from the function cosine of theta, we know that that angle is 2 pi. So that means that omega times t is exactly 2 pi. And that is my final result.